The glass manufacturing process begins with a carefully measured blend of raw materials: sand, recycled glass, known as cullet, limestone, and soda ash. Recycled glass is a crucial component, as it reduces the need for virgin raw materials and lowers the energy required for melting. The mixture is fed into a furnace operating continuously at about 1,500 degrees Celsius, where it is transformed into molten. The glass manufacturing process begins with a carefully measured blend of raw materials: sand, recycled glass, known as cullet, limestone, and soda ash. Recycled glass is a crucial component, as it reduces the need for virgin raw materials and lowers the energy required for melting. The mixture is fed into a furnace operating continuously at about 1,500 degrees Celsius, where it is transformed into molten glass. From the furnace, molten glass flows through narrow channels called feeders. It passes through an opening at the bottom, where it is cut into equal portions called gobs. These gobs are delivered to blank molds in an individual section forming machine. There are two main forming methods: blow and blow. Compressed air first forms a cavity in the gob, creating a partially shaped container. The piece is then transferred to a blow mold, where compressed air again shapes it into its final form. Press and blow. A metal plunger presses the initial cavity in the blank mold, followed by compressed air shaping the container in the blow mold. Once formed, containers are reheated and slowly cooled in an annealing leer, a long, flat oven that prevents internal stresses. This process can take from 30 minutes to 2 hours, depending on the container type. During annealing, two surface treatments are applied: hot end coating to maintain strength, cold end coating to prevent scratching during handling. Quality control is rigorous. Sensors and probes check sealing surfaces, dimensions, wall thickness, and detect imperfections. Any defective containers are removed from the line, crushed into cullet, and fed back into production. Finished bottles and jars are packed onto pallets using reusable or recycled materials, then wrapped for protection during storage and transport. They are shipped either directly to customers or to decoration facilities for branding. In Step 1, high-purity sand, soda ash, limestone, and cullet are carefully selected, cleaned, and inspected to remove impurities, ensuring the glass mixture meets precise chemical composition requirements for strength and clarity. In Step 2, each raw material is weighed with high precision and mechanically blended, ensuring a uniform mixture that maintains consistent melting behavior, chemical balance, and product quality in every glass batch produced. In Step 3, the precisely mixed batch is fed into a high-temperature furnace, heated to around 1,600 degrees Celsius. Here, the materials melt into a homogeneous molten glass called gob. The furnace operates continuously to maintain a stable temperature, prevent defects, and optimize energy efficiency, ensuring consistent quality for subsequent forming processes. In Step 4, molten gobs of glass are shaped into bottles through specialized forming methods. For narrow neck bottles like beer, wine, or soda, the blow-and-blow process is used. Compressed air shapes the gob into a preliminary form called a parison, which is then reheated, flipped, and blown again to achieve the final contour. For wide-mouth containers such as vases, jars, or milk bottles, the press and blow process is preferred. A plunger presses the gob into a parison mold, which is then transferred, reheated, and air-blown to its final shape. Both methods ensure precise dimensions and consistent quality. In Step 5, bottles pass through an annealing layer, gradually reheated and cooled to relieve internal stresses, enhancing durability and strength. In Step 6, every bottle undergoes rigorous inspection using automated detection systems and skilled visual checks. Defects such as cracks, bubbles, thin walls, deformation, or seams are identified. Faulty bottles are immediately removed from the production line, ensuring only structurally sound, visually flawless glass bottles proceed to surface treatment and packaging. In Stage 1, high-purity silica sand, soda ash, limestone, and recycled cullet are precisely weighed and blended into a homogeneous batch. Optional metal oxides or colorants may be added at this point to achieve specific glass colors or functional properties. The blended batch of silica sand, soda ash, limestone, and cullet is fed into a refractory-lined furnace operating at 1,565 degrees Celsius, 2,850 degrees Fahrenheit. Over a 24-hour melting cycle, extreme heat transforms the raw mix into a homogeneous molten glass free from impurities. This molten glass then flows into a forehearth, where its temperature is carefully stabilized to ensure uniform viscosity. From here, a plunger pushes the glass through an orifice ring, producing continuous streams that are cut by mechanical shears into gobs, precisely measured portions ready for shaping. Depending on the container type, gobs undergo either the press and blow, narrow neck press and blow, or blow and blow method, where controlled pressing or compressed air forms the final glass container shape. XPAR technology uses dual-camera thermal imaging to compare each bottle in real time, detecting thickness variations by measuring heat radiation, ensuring defects are identified and removed before further processing. Bottles pass through a long, temperature-controlled annealing layer, where they are reheated and slowly cooled to relieve internal stresses, greatly enhancing durability and resistance to cracking. Every bottle undergoes rigorous electronic, mechanical, and manual inspections to detect imperfections. Defective containers are removed for recycling, ensuring only flawless, high-quality bottles proceed to filling or shipment. It begins with the careful selection of raw materials. The primary components are extremely pure sand, soda, and lime, which make up about 95% of the mix. The remaining 5% consists of additives that influence the glass's mechanical, chemical, and optical properties, as well as its melting and refining characteristics. Recycled glass, known as cullet, is added to reduce energy consumption and raw material use. These materials are transported on conveyor belts to mixers, producing a homogeneous batch ready for melting. The batch is fed into a pot furnace, where it is heated to around 1,500 degrees Celsius. At this temperature, the ingredients fuse into a homogeneous, viscous molten glass. From the furnace, molten glass flows through feeders, which precisely portion it into gobs, measured balls of molten glass whose weight depends on the intended container size, ranging from 35 grams for small flasks to 5 kilograms for large bottles. These gobs are delivered to individual section forming machines where automated production ensures consistency. The forming process occurs in 2 stages. First, the gob is shaped into a preliminary form using molds and either compressed air or pressing methods. This blank is then transferred into a finishing mold, where compressed air gives it its final bottle or flask shape. After forming, bottles undergo heat treatment to ensure structural integrity. They are reheated to approximately 560 degrees Celsius, allowing temperature equalization and relieving internal stresses through annealing. The cooling process is gradual, lasting from 1.5 to 4 hours depending on production speed. Following annealing, Bottles receive a cold treatment to increase surface friction, reducing the risk of scuffing and improving handling during transportation and bottling. Each bottle is subjected to rigorous inspection. Automated systems check dimensions, bore diameter, glass thickness, and detect defects or brittleness. Bottles failing to meet strict quality standards are destroyed and recycled. Once approved, bottles are stacked on pallets, shrink-wrapped for protection, and prepared for shipment. Saverglass's strategically located plants, 3 in France and 1 in Ras Al Khaimah, UAE, enable efficient global distribution. The company also operates decoration facilities, specializing in acid etching and frosting, allowing for bespoke finishes tailored to premium branding. Producing over 620 million bottles annually, with 45% exported to more than 80 countries, this process exemplifies the fusion of traditional craftsmanship with modern automation, delivering premium glass bottles that meet the exacting standards of high-end wine, spirits, and perfume producers worldwide. Inside the roaring furnace, the intense gas flame heats the sandy mixture to over 500 degrees Celsius, breaking down its solid grains and transforming it into a shimmering pool of molten glass. This glowing liquid flows in a steady stream toward heat-proof shears, which snip it into thick, honey-like blobs called gobs. Guided down steel chutes, each gob drops into a mold, where a worker cleans with an oily stick just in time. The first mold shapes the neck. The second uses compressed air to form the complete bottle. Fresh from the molds, the bottles are still warm and relatively soft, so they need extra protection before handling and packaging. To achieve this, they are coated with a very thin but effective layer of monotyl tin chloride, a chemical with an intimidating name but a vital role. This invisible coating prevents the glass surfaces from scratching each other during transport, stacking, or while moving along conveyor belts. Even microscopic scratches can weaken the glass, so this step is essential to ensure durability. Once coated, the bottles aren't cooled abruptly, as that could cause stress fractures. Instead, they are kept warm and moved into a tempering machine, where they cool down gradually over a controlled period. This annealing process relieves internal stresses within the glass, making the bottles stronger and more resistant to cracking. When the bottles reach room temperature, they are lined up for testing. The first test checks whether the bottle's mouth, the opening where the cap will later be fitted, is the correct size. Any deviation could cause sealing problems during filling. After this, the bottles move into the inspection chamber, a brightly lit area where high-speed cameras scan each bottle for cracks, bubbles, or deformities that could compromise safety or quality. Those that fail are immediately rejected, crushed, and sent back to the furnace as cullet for recycling. The bottles that pass inspection are stacked, packed, and prepared for delivery. The next stage happens at the bottling factory. Here, the drink, whether it's water, soda, juice, or beer, arrives in large stainless steel tankers. After quality testing, 2 connections are made: an extraction pipe at the bottom to draw out the liquid, and an air pipe at the top to pressurize the tank. A compressor pumps air in from above, pushing the drink out from below and into the filling machine. Meanwhile, bottles, often browned to protect the drink from light, are checked again for cleanliness, rinsed with purified water, and drained upside down. The filling machine works with remarkable speed, precisely dispensing liquid into each bottle before capping them in a swift, mechanical twist. If any froth remains at the top, the bottles receive a hot shower in the pasteurizer, where they stay for a couple of hours to kill any stray bacteria. Once pasteurized, the bottles are dried, labeled, and made ready for shipment to shops, bars, and homes. The outer wall of the furnace is best made from a steel paint can, around 2.5 liters in size, with a minimum diameter of 150 millimeters and height of 160 millimeters. Steel is essential because its melting point, about 1500 degrees C, is far higher than aluminium's, about 650 degrees Celsius. Drill ventilation holes in the base and lower sides to improve airflow, raise combustion temperature, and allow ash to fall out. Larger cans can be used but require more fuel. The crucible holds the aluminium while it melts and must be made of steel to withstand high temperatures. A simple tin can works well, provided it fits inside the furnace with enough space around it for fuel and airflow. Dry hardwood or scrap wood works best as fuel, cut into pieces about 1 inch thick and 1 to 2 inches long. This size ensures steady, efficient burning without consuming fuel too quickly. Charcoal is also suitable. Keep extra fuel ready, as you'll need to replenish it during the melting process. An air supply is vital for reaching the high temperatures needed to melt aluminium, as wood alone often burns too cool. By forcing extra oxygen into the furnace, combustion becomes hotter and more efficient. A hairdryer is the easiest option, but a hot air gun or small blower works well too. Position the furnace on 2 bricks so air can enter from underneath and ash can fall through. Direct the airflow toward the base holes, ensuring a constant, strong oxygen feed throughout the melting process. To use the furnace, first place it on 2 sturdy bricks to raise it off the ground, allowing air to flow underneath and ash to escape. You can light the fire in one of 2 ways: the traditional method, which involves placing paper or other tinder at the bottom, adding fine kindling on top, and then layering larger pieces of wood above, or the quicker method, where the furnace is filled with wood and a small amount of lighting fluid is added before ignition. Once the fire is burning steadily, allow the furnace and crucible to heat up so any paint or coatings burn away. This step should be done at a safe distance to avoid inhaling fumes. When the flames are established, place the crucible into the furnace and surround it with additional fuel, maintaining at least a 35 mm gap for airflow. Switch on your air supply, hairdryer, hot air gun, or blower, and direct it toward the base holes to increase combustion temperature. Add small pieces of aluminium to the crucible. Smaller chunks melt faster, though larger pieces will melt given enough time. During melting, monitor the fuel and add more as needed to keep the fire hot. When the aluminium is fully molten, carefully lift the crucible with steel pliers, avoiding plastic grips that might melt. Pour the molten aluminium into a prepared mold, such as a sand cast. Always wear gloves and goggles, and work in a safe, well-ventilated outdoor space away from flammable materials. The Riedel Sommelier wine glasses are celebrated worldwide as the pinnacle of stemware craftsmanship, representing a perfect blend of tradition, precision, and artistry. Each glass in the Sommelier series is mouth-blown and handcrafted by highly skilled glassmakers, ensuring that every piece meets the brand's uncompromising standards for quality and performance. The production process begins with carefully selected raw materials, including the purest crystal glass, chosen for its brilliance, clarity, and ability to showcase the wine's color and texture. Master glass blowers, often with decades of experience, work in teams to shape the molten crystal. Using age-old techniques, they gather the material from the furnace, skillfully blow it into preformed molds, and then freeform shape elements such as the bowl and stem with precision tools. The hallmark of the Sommelier series lies in the seamless integration of design and function. Each glass is shaped according to Riedel's research into how the vessel's dimensions, rim diameter, and bowl curvature influence a wine's bouquet, flavor, and balance. This means that every varietal-specific design is the result of rigorous testing in collaboration with sommeliers and winemakers, ensuring that the glass elevates the sensory experience of the wine it holds. Once the glass is shaped, it undergoes meticulous inspection to eliminate any imperfections. The stem, bowl, and base must align perfectly, and the glass must be feather-light yet strong enough for practical use. The finished pieces are polished to a flawless shine, highlighting the natural brilliance of crystal and the precision of the craftsmanship. Because each sommelier glass is made entirely by hand, no two are exactly alike. Each is a unique work of art. The process is labor-intensive, requiring both technical skill and artistic sensibility, yet the result is stemware that combines elegance with unrivaled performance. For over 4 decades, the Riedel Sommelier series has been the choice of wine connoisseurs, Michelin-starred restaurants, and collectors around the world. These glasses are not simply drinking vessels, they are finely tuned instruments, crafted to unlock a wine's full potential, making every sip an elevated experience.